Hello everyone. In this video, we are going to introduce an important concept in programming languages, which is dynamic memory allocation. So what exactly is dynamic memory allocation? It refers to the ability to request and manage memory from the system during runtime. And this allows us to control how much memory our program uses while it's running. Okay? And there are three main actions involved in dynamic memory management. The first action is allocation. We will use malloc function or calloc function. The next action is initialization or setting values. We will use manset function. And last action is resizing memory. We will use realloc functions. Okay, so previously, when we declare variables, we will write something like integer a equals 10. And this is called static allocation because the memory size is determined at the time of declaration. But for dynamic allocation, we need to use pointers to point to memory space we request from the system. For example, if we want to allocate memory for storing integers, we can write it like this. Okay, here's malloc function is used to allocate space for 100 integers. And because malloc returns a generic pointer, we usually write it as void pointer. Okay, and we need to cast it to integer pointer. And at this point, the pointer a points to the allocated memory. However, malloc function doesn't initialize this memory, so we can use manset function to set it to a default value. We can write it like this. Okay, so the manset function takes three arguments. The first one is the pointer to the memory, and the second one is the value to set. In this case, we set it as 0. And the last one is the total size of the memory to set. So you can think of malloc function and manset function as a pair. One allocates memory and the other initializes it. If you want to simplify this, you can use calloc function, which allocates and initializes memory to 0 in one step. So you can write it like this. Okay, so the first argument is the number of elements, and the second is the size of each element. Calloc function automatically sets the memory to 0, so you don't need to call manset function to initialize the memory. So far, you probably think of it works just like an array. Yes, we can use brackets and indexes to access and modify elements. We can write it like this. Okay, this loop sets each element to its index and prints that. Let's run it and check out. Okay, besides using brackets, you can also use pointer arithmetic and dereferencing. If you want to assign values using this method, you can write it like this. Notice that how pointer a at the index I is wrapped in the parentheses before dereferencing. This ensures the pointer moves first and then gets dereferenced. So if you write it like this, it is incorrect. the compiler will show an error. This is because you are adding a value to the dereferenced value and trying to assign a result to an expression, which is invalid. So, to avoid such errors, it is safer to use the bracket notation, unless you are confident with pointer arithmetic. These tricky syntax issues are also common interview questions. Alright, now we are getting to the final key point. So far, everything we've done is pretty similar to working with arrays, but as I mentioned at the beginning, when we declare variables or arrays, we typically use static memory allocation. This means the size is fixed when the program is compiled, and it is not easy to change it later. The advantage of dynamic memory allocation is that we can resize a memory block at any time. For example, we can do this. Okay, the reallocate function takes two arguments. The first one is the pointer to the memory, and the next one is how much memory we need. And there's one very important thing to note here. When using the reallocate functions, it is best to assign the result to the new pointer instead of overwriting the original pointer. Why? Because functions like malloc, calloc, and realloc do not guarantee that they can successfully allocate the requested memory. If the allocation fails, these functions return a null pointer. So, if you directly assign this to your original pointer and the allocation fails, then you will lose the reference to the previously allocated memory, causing a memory leak. That means the old memory block is still reserved, but you have no way to free it anymore. So to avoid this, write your code like this. First check whether the new pointer is null pointer. And next, we will use loops to fill and print the newly added memory space. Since we already initialized the first 100 elements earlier, now we only need to modify the next 100 elements. So we can start our loop from index equals 100. Okay, let's go through all 200 elements now to see what we have in memory. You might notice a wavy underline in your editor at this point. That's a warning, not an error. It is because pointer A was originally declared as null pointer. And like we just said, functions like malloc, calloc, and realloc might fail. So when you try to use pointer A, the editor is warning you might be accessing a null pointer. This can lead to your program crashing at runtime if you don't handle it properly. So what should we do? We should always develop the habit of checking if a pointer is null before using it. If it is a null pointer, just return or handle the case accordingly. What we return depends on what functions is supposed to return, but the key is never access a null pointer. Finally, there's one very important step to wrap up. If you no longer need the dynamically allocated memory, make sure to free it. If you don't, it will continue occupying memory while your program runs. This is another case of a memory leak. So you can release it like this. Just use the delete keyword to free the memory, and then set the pointer to null pointer to avoid any accidental access to a freed memory block. Alright, in this video we covered the basics of dynamic memory allocation, including relevant functions and how to use them. I encourage you to practice it more on your own. See you in the next video.